Germany is planning the energy transition. But with regard to this, we're not just talking about electricity. The German federal government is aiming to generate renewable energies to cover 30% of gross electricity consumption by 2020. But it only plans to cover 14% total heating requirements with renewables. Here it should be noted that the proportion of heat production in Germany is 1,400 terawatt-hours. This is far higher than the proportion used for electricity generation, 620 terawatt-hours. Around 888 terawatt-hours are required just for room heating and hot water requirements. In the foreseeable future, the established renewable energies alone will not be able to cover this demand. For wind power, photovoltaics and geothermal energy, there are not enough locations, consistency in energy supply, or possibilities for storing energy. In many places, new installations attract public opposition. Without supplementary technologies, the energy transition is a task which can scarcely be fulfilled. But there is no time to lose. Potentials are available. Not only policymakers are called upon to tackle the energy problems. Industry must make a major contribution. Above all, key energy-intensive sectors have a responsibility, and one of these is the water industry. After all, water supplies and wastewater disposal require energy, a lot of energy. Often the wastewater treatment plant is a local authority's biggest consumer of energy. But there is also plenty of energy in wastewater. Every day, vast amounts of energy that have already been paid for are flushed down the drain. Through showering, cooking, washing clothes or dishes, millions of cubic meters of hot water are discharged into sewers without tapping their potential. Its energetic potential, around 80 terawatt-hours. According to the latest study by the University of Stuttgart, this is equivalent to about 9% of the annual energy requirement for room heating and hot water in Germany. According to the study, every 10th building could hence theoretically be provided with heat from wastewater. Making this heat energy available for use is very simple. The principle has been known for over 30 years. Appropriate technologies have been used for a long time. The flow of warm wastewater, which is between 10 and 20 degrees Celsius all year round, is discharged into the sewer network via heat exchangers, which transfer this energy to an intermediate cycle. A heat pump pumps the heat to the required energy level and provides it to the final customer. However, heat pumps are not only suitable for heating. During the summer months, they can use the relatively cold flow wastewater for air conditioning in buildings. Their efficiency is greatly improved through combining heating and cooling. The enormous potential for using wastewater heat would be increased several times if industrial waste heat could also be used. Smoking cooling towers are a familiar scene, because virtually every industrial process generates waste heat. Up to now, its energy in temperatures ranging from 20 and 55 degrees Celsius is discharged into the atmosphere without being utilized, discharged into waters in return for high charges, or cooled in cost-intensive processes. The wastewater potential of industry and power plants in Germany: approximately 685 terawatt-hours, more than 3/4 of total heating requirements. This vast energy reserve can be made available through the local heating sewer network. Instead of discharging excess energy into the environment and senselessly wasting it, waste heat can be discharged via heat exchangers into the existing sewer network. While the temperature of the industrial cooling media is reduced to the required level without additional use of energy, it increases by several degrees in the sewer network and can be transported with the flow of wastewater. Downstream, where a suitable heat consumer is located, the energy is drawn out of the wastewater by an additional heat exchanger. Modern sewer network management systems enable the above-mentioned energy flow to be controlled according to requirements. Sewage network management is no longer a vision of the future. Today, this technology is already used in several cities. Such systems can also be used for controlling heat. Using weirs which regulate the sewer cross-sections, fluctuations in flow are compensated and flows of wastewater are directed according to settlement water management criteria or heat criteria. In this way, energy can be directed to the user or even stored. Discharging heat into the sewer network even during summer, when the absolute wastewater temperatures are naturally higher, does not have any negative impacts on processes in the wastewater treatment plant, because of the heat storage capacity of the ground. If the temperature level increases in the sewer network, some of the heat is discharged into the surrounding ground. If the wastewater temperature falls, the ground radiates the energy back into the sewer network. Hence, discharges of water are compensated for along the course of the flow of wastewater. If recooling of the wastewater is necessary before the wastewater enters the sewage plant, groundwater wells combined with heat exchangers provide a simple technical solution. Using such a local heating sewer network, which intelligently controls flows of wastewater through including the use of industrial waste heat, many municipal households could be provided with energy all year round for room heating and hot water. The efficiency of this innovative form of energy is above all influenced by the wastewater temperature. If the temperature level increases in the sewer network due to discharges of industrial waste heat, the heat production costs are reduced compared to fossil energy carriers. If expected increases in energy prices are taken into account, this effect is even greater. The heat pumps require little primary energy, and their efficiency is increasing. Utilization of wastewater heat is a non-subsidized technology. If energy from wastewater was subsidized at the rate of 1 cent per kilowatt-hour, the CO2 recovery efficiency would be 7 times higher than for photovoltaics, around 30% higher than for hydropower, and the same as for wind energy. Hence, the advantages are obvious. Instead of expensive imported energy, Germany will use an energy carrier which is constantly available and has already been paid for. The environmentally friendly technology preserves fossil resources and can make a substantial contribution towards saving on climate-damaging greenhouse gases. Investments in wastewater heat utilization help industry to save costs and to keep added value in our own country. Since such plants are completely invisible, they are widely accepted by the public and are associated with an improved image for initiators and operators. Altogether, the utilization of industrial waste heat in local heating sewer networks is therefore excellently suitable for economic stimulus programs. Today, the fairly recent technology of wastewater heat utilization has already been implemented in numerous projects.